Calculus examples. The quotient rule. This is video 8. How to determine when the quotient rule must be used. It includes exercises with solutions. The following list of 5 short videos shows all videos, including this one, that involve the quotient rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. An example of a function that is the quotient of 2 separate functions. The function y, where y equals 7x cubed divided by 4 plus e to the x, is the quotient of 2 separate functions on the right-hand side of the above equation, circled briefly in purple. The numerator is 7x cubed and the denominator is 4 plus e to the x. Since y is the quotient of 2 separate functions, the derivative of y must be found using the quotient rule. The notation for the derivative of y is y dash x or dy by dx. Further examples. Each of the following functions is the quotient of 2 separate functions. Identify the functions. 1. 2x plus 1 is the numerator, and x minus 2 times x plus 1 is the denominator. 2. 7 plus v is the numerator, and 2v times e to the v is the denominator. In this case, the derivative of p will be p dash v or dp by dv. 3. E to the u is the numerator, and 1 plus e to the u is the denominator. In this case, the derivative of f will be f dash u or df by du. Exercises. Each of the following 6 functions displayed without commentary is the quotient of 2 separate functions. Identify the functions. You should pause this video now and complete all 6 questions. Then check your answers with the solutions on the next screen. Solutions to the exercises. The solutions below are displayed without commentary. The derivatives of the above functions must be found using the quotient rule. Questions 5 and 6 are discussed on the next two screens. To review the above solutions, you should pause this video now. 5. 3t to the fourth minus 5t cubed plus root t is the numerator, and t squared is the denominator. However, the quotient rule can be avoided completely by simplifying the right-hand side of f as follows. Equals. First, divide each term by t squared. 3t to the fourth becomes 3t to the fourth divided by t squared minus 5t cubed becomes 5t cubed divided by t squared plus root t becomes root t divided by t squared. Then replace root t with t to the half equals. Replace t squared in the denominator with t to the minus 2 in the numerator. 3t to the fourth stays as 3t to the fourth times t squared in the denominator becomes t to the minus 2 in the numerator minus 5t cubed stays as 5t cubed times t squared in the denominator becomes t to the minus 2 in the numerator plus t to the half stays as t to the half times t squared in the denominator becomes t to the minus 2 in the numerator. This is Law 7 in the reminder on the last screen of this video. Equals. Apply the law of exponents that states that b to the x times b to the y equals b to the x plus y equals 3t to the 4 minus 2 becomes 4 minus 2 minus 5t to the 3 minus 2 becomes 3 minus 2 plus t to the a half minus 2 becomes a half minus 2. This is Law 1 in the reminder on the last screen of this video. Equals. Simplify the exponents. 3t to the 4 minus 2 is 2 minus 5t to the 3 minus 2 is 1 plus t to the a half minus 2 is minus 3 over 2. Now replace t to the 1 with t. Since f of t equals 3t squared minus 5t plus t to the minus 3 over 2, using the power rule, f dash t equals 6t minus 5 minus 3 over 2 times t to the minus 5 over 2. So the derivative of f has been found far more easily and with less chance of error than if the quotient rule had been applied to the numerator and denominator in the original equation. 6. Z squared minus 1 is the numerator and z minus 1 is the denominator. Once again, the quotient rule can be avoided completely by simplifying the right-hand side of h as follows. Equals z squared minus 1 is the difference of two squares, so replace it with z plus 1 times z minus 1. Divided by z minus 1 equals as above. Now cancel the factor z minus 1 in the numerator and the denominator. Equals z plus 1, z not equal to 1. Once you cancel z minus 1 in the numerator and denominator, you must add z not equal to 1, as shown. The reason is given in the reminder on the next screen. So since h equals z plus 1, z not equal to 1, using the power rule, h dash z equals 1, z not equal to 1. Thus the derivative of h has been found far more easily and with less chance of error than if the quotient rule had been applied to the numerator and denominator in the original equation. If you got one or more of these questions wrong, return to the exercises. You should try to understand what was wrong and why you got them wrong the first time. Then repeat the questions until you get them all correct. When solving questions from your textbook similar to the questions in the exercises, you will find it helpful to have the solution screen displayed so you can use it as a template. You should then find this topic simple and beautiful. Cheers. Reminders displayed as references without commentary. To review the above reminder, you should pause this video now. To review the above laws of exponents, you should pause this video now.